everyone, it's Corey with Emsley Technical Solutions. I wanted to jump on today to show you guys some of the um, fun workflows that we've been playing with our new Leica 360, our BLK 360 laser scanner. Um, this is a scan that JD and Rory put together that we did over at the one of the performance spaces over at DU University here in Denver, Colorado. This is their Hamilton space. And its main function is a music performance venue. And they were kind of enough to let us come in and scan. And actually, has this really beautiful organ back here that was a fun subject for us. Um, Anyways, I digress. So we've been kind of refining our workflows when it comes to reality capture and scanning technology, just because it has so much benefit downstream to all of the different parties, design, technical design, so that everyone knows exactly what kind of space you're dealing with and can design and act accordingly. So what we're looking at right here is each of these red circles represents an individual scan that was performed. The software that we're in right now is called Register 360, and it's a Cyclone Register 360. It's part of the Leica suite of software that they deliver with the scanner, and this is what we utilize to collate the scans, have them register against one another. We use a variety of different targets and methods to make sure that that's accurate and that those scans create an overall point cloud. Each of these points is an actual distance value from one of these scans, and then when they're all registered together, you get a really cool, clear picture of the overall space. So when we're done with this, we can export this report and these point clouds in a variety of formats. With the Autodesk software we use the RCP because that's what AutoCAD and Inventor can consume. But there are point cloud compatibility with most CAD softwares out there now. SketchUp has it, SolidWorks has it, I believe Vectorworks has it, and so we can output in a variety of formats so that your design or CAD teams can get the details they need to do their job effectively. So for us, I pushed it into an Inventor file, and that's what we're looking at over here. And I one time I had to do a site survey for like a sound stage, like a small intimate recording studio, and the geometry of the room was such that I spent 3 days doing the initial site survey. I had to come back another 2 times because I had missed details in the ceiling or that were important to the design later on. So even though you might think you've gotten all the details that you need when you come to doing your technical design with really intricate designs, you may be missing a detail. And with a point cloud, you just don't have to go back. You just get everything, which is really nice. So what we're looking at here is we're in an Inventor part space. We've brought in the RCP file from that scan, from the collated scan into Inventor. I'm going to do, we brought it in using this point cloud attach function here, but I'm going to do a box crop, which is going to, it's a lot of data here, so this is going to just kind of scream at me for a second, so just bear with me. Anyways, while that kind of renders and deals with cropping out all of those overhead, perfect. That didn't take too long. Awesome. So, and we'll get to that in a second. So what we've done here is we've kind of cut the flooring about 4 feet off of the ground. So from here I can actually just start in plan view and start sketching the extents of the space. And that's actually what I did here. If I was to hide others, perfect. With this sketch, I created a plane on the floor, which you can do here with the cloud point or cloud plane function in Inventor. A lot of different software has the ability to create reference geometry off of those point cloud faces. An interpolation of points that creates a plane. Anyways, so what we've done here is we've created just like a small example of what a small set might look like if this space was like a theater space and they wanted to put a series of walls up to kind of capture the space and make it more intimate or to do what have you. So we've put these walls and we've put like a 40-inch restriction off the back and kind of made a series of walls that are 2.5, let's make them 3 inches thick. 3 inches thick that sit on this plan floor. So what we were able to do is just create a sketch and just start using the end of all of these points to create our reference for where the end of these walls were. Um, we sketched that in, and we have a very real reflection of exactly where this was, because really what we were clicking against is the edge of that baseboard. And so we're able to really accurately measure and have a reference for exactly where this is, be able to really clearly talk to production about egress details or any other negative implication of the designs. And another reason this is valuable is once you start modeling and actually creating geometry from those sketches with this point cloud, if we go over here and we turn off that box crop, we can see that this wall, if the design calls out for a 10-foot wall, if you just had the plan view of the floor space, you wouldn't know that this wall pitches in and that you have a conflict here, right? So either this wall needs to shrink or that offset from the back wall needs to change. So these are the kind of details and problems that you're going to be able to just to kind of deal with and handle in design space, rather than having to send someone back to the site, have them take more site measurements, send them back to the shop, draft those details up, and then move forward from there. I'm going to do another box crop here just to the top of the wall so we can more clearly see that issue. And right, I'm able to just start working. I can just start modeling and doing my work, and I have a clear representation of exactly what conflicts or problems I'm going to have to deal with in the space. So we see this as a super valuable tool moving forward. When we have complex geometry and complex as-builts that we need to work with for our clients, we're encouraging them to have a scan performed, and for us to travel out, or for another party just to get a scan one way or the other, so that we can move forward, accurately know exactly what's going on with the space, and get to the finished project and get to fabrication as quick as possible. So some really cool things. Wanted to show you guys really the benefits and the strengths of this kind of workflow, and I hope you found this entertaining. If you have any other questions about this technology or how we're using it, or our workflow, feel free to shoot me an email, and have a great day. Thanks, guys. Bye.